Two and a Half Admins, episode 247. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Furacul, who's a patron, wrote to us. During episode 245, while discussing tiered storage, Alan mentioned that dealing with cache was a problem pointed out back in the 40s. That made me think of the old joke about there being only two hard problems in computer science. So, we can't do tiered storage other than by guess and by golly, because we just don't know how. What other issues are sysadmins likely to run up against that there just aren't good solutions for exactly the same reason? Nobody knows.
So before we can tackle this one, I think we need to talk about what the only two hard problems in computer science really are.
Yeah, that's cache invalidation, naming things, and off by one errors.
Or, if you prefer, cache invalidation, naming things, and cache invalidation.
Yeah. So cache invalidation, which comes up very frequently, is when you have cache to be able to quickly get a copy of something. If you change the something, but don't delete the cached copy or force overwrite it with the newer copy, then the cache still has yesterday's version of the information, not today's version. And you keep feeding the cache version to people, and the newer version just sits there getting unused. And so working off old information is bad. And so while you need the cache to be able to work fast, if it doesn't get invalidated when you delete or rename something, then it can cause all kinds of mayhem. And then obviously naming things is always difficult. No matter what you name it, somebody else has already used that name for something that means the opposite, or we have all of these examples of that, like KVM, right? That as to a sysadmin, that always meant the keyboard, video, mouse. It was a switch that let you run multiple computers off one, monitor, keyboard, and mouse. And then suddenly it became kernel virtual machine and actually means a VM. And it's like these two things are in the same space and mean not the same thing. And I wish they wouldn't have done that.
I also really wish they wouldn't have done that. And that caused me a lot of genuine confusion in the early days of KVM. There were a lot of conversations. I could not figure what the hell people were talking about because they kept talking about the weird stuff that KVM was doing. And I'm like, what the hell does that have to do with the keyboard, video and mouse thing in the rack to let you, use the crash cart with multiple servers? I don't get it.
And I remember the ones that had like weird keyboard shortcuts, like press scroll lock F2 in order to switch to the second terminal or whatever. And I could see that somehow screwing with things, but yeah, it didn't make any sense to me.
Moving back to Furacal's question about what other issues sysadmins tend to run up against that there really is no known good solution for, I think before I tackle that directly, I want to point out that it's not so much that nobody knows how to do cache invalidation or nobody knows how to do tiered storage. The problem is that there's no one universal answer. It has to be tailored to each individual workload, and you very rapidly discover that the majority of administrators don't actually even understand their own workload that well. And even in the cases where they do, it's very frequently not a case of, I have one workload with one set of characteristics. You are doing a whole lot of different things on essentially the same set of hardware with the same topology, and you can't really tune it for all of them at once. So you have to make hard decisions, and you have to think about those decisions pretty hard every single time because every time is different. So with that said, are there other cases like that where there is no one good way to do things, or there may not be any way to do it at all? I would argue that the most obvious example of that to me is the concept of eliminating a single point of failure. We like to tell ourselves that, oh yeah, we just eliminate the single point of failure and, that way our systems are perfectly fine all the time. But no, you don't. You can minimize the number of single points of failure you have, but you always end up with one. You can't do away with it. It's a chicken and egg kind of a thing. Ultimately, everything has to come back to some kind of a root. And there's going to be something that can fail and make it not work right. Databases are usually the most difficult thing to get right with this. They're certainly not the only one. Anything up to and including file storage, you name it, it gets tough because when do you throw things to which head? How do you determine whether or not one head has stale data? How do you determine which of the heads, when they disagree, is the right one to, give precedence to? How do you determine when to kick one out? How do you make sure when this head thinks I'm the only one left, I should be the primary now and everything else should be demoted to secondary or kicked out of the cluster? how can it be certain whether or not it is? And if you're not letting every single peer do that for themselves, in which case you run a major risk of running into a split brain scenario where you've got multiple primaries distributing data like a shotgun blast all over the place. If you've got a separate load balancer, well, guess what that is? It's a single point of failure. Now, does that mean that having a hardware load balancer in front of a pair of application servers is a terrible idea? No. Assuming the economics of it work out right, that can frequently be a good decision, and here's why. Although the load balancer is a single point of failure, ideally the load balancer will be a much, much simpler to configure and replace single point of failure. Where if you lose an entire fully configured database-backed application server and have to recreate the whole thing from scratch, then that might be a lot of work versus, oh no, the F1 died. Oh, that's terrible. Grab another one out of the closet and slap it in the rack and we're good to go. That starts looking pretty compelling. But we're still talking about there is a single point of failure. There always is. If you think there isn't, I invite you to look at your application again.
It's interesting that so many of the problems you described actually boil back down to cache invalidation and distributed systems. Because part of the problem with like the two-headed storage system is literally if one of them thinks is in charge and reads from the disk and caches that result, and then the other head changes something on the disk without the first head knowing it, the cache doesn't get invalidated. And that's where you get these problems of the split brain situation and so on. And you're building a distributed system, right? Where you're trying to have one state between two different machines. And it turns out that's really hard. And databases are basically all cache invalidation and distributed systems. And so a lot of these very basic problems kind of crop up in every different thing that we try to do across every layer of the stack in tech.
It's a little bit more general purpose, less buzzwordy restatement of a complaint that I make pretty frequently on this show, which is that high availability is not what the vast majority of sysadmins seem to think it is. High availability, in my experience, it makes crashes somewhat more likely, not less likely. If you're running a full HA stack, you need a more experienced team that needs to pay a lot of attention to how that HA stuff works and test it and monitor it and make sure it's in good condition. Because if you don't have that, what winds up happening is something finds the single point of failure in your HA solution and you have a much, much uglier problem when it does than you would have with a simpler system without the HA.
Yeah, because basically when you add that kind of HA, you take a straightforward system and turn it into a distributed system where now all of the parts have to be lined up the right way or things don't work. And you've added that many more parts and that many more points of failure.
It's like how we always say RAID is not a backup. Well, why isn't RAID a backup? Because it's just littered with single points of failure that a proper backup pushes a lot further down the road. When you've got just simple RAID, take out the drive controller, you just took out the RAID. Take out the power supply in a really nasty way that sends power down, through the entire storage network. You just lost the array. A malicious administrator that just formats everything. You just lost the array. I mean, we could go on forever with this, but I think the more useful point here that I really want to make the comparison is that we also warn people when it comes to RAID. A lot of people have this idea, well, I've got 12 disks in a redundant configuration, so obviously my data is a lot safer than it would be without that. And the thing that they haven't considered is that, well, okay, but if all your data would have fit onto one drive, then that would have been one point of failure on that one drive. Well, you added some redundancy, but you also now have 12 times the chance of failure at any given instant because you have 12 times as many of the same kind of hardware, all of which can fail. So these are the things that you really have to consider and that make this kind of thing a lot tougher than people think it is. To the point where, again, I'm arguing that in the way that people widely understand it, it's a sham. You can't eliminate single points of failure. You can just reduce them and choose which ones they are to be the easiest ones to deal with when they do fail.
I think one of the other ones we have kind of already talked about, but this whole concept of distributed systems, but especially databases. Keeping multiple bits of a database in sync is really complicated, and doing it quickly is even more complicated. And in my experience, the only worldwide replicated database that actually works every single day is DNS. And we all know that DNS doesn't update that fast. It updates reasonably fast, But it's not, you're thinking like your transactional database that's running all the big e-commerce websites or something. The speed of DNS wouldn't make sense there. But the fact that you can make a change and it's basically we've delegated all these different parts of the database to different people, and this one single giant database is available all the time and just works, and we can look stuff up reasonably quickly, is a miracle, because every other database solution has some other set of trade-offs where, we can be sure that every node has the same information, but it'll take a really long time. Or we can update really fast, but we're only sure that the two closest nodes have the data. Everybody else, who knows what state they're in? You got your eventually consistent database. And in all these cases, there's no perfect solution. Like Jim alluded to at the beginning, there are a whole set of trade-offs, and there are different solutions that have different values of those different trade-offs. But I don't know that we could actually say it's a solved problem, because there's not one kind of solution that works for everything.
And the only reason it works as well as it does with DNS is because DNS is by its very nature a very tightly constrained application with very similar needs, regardless of like what kind of website or, which computer you want to have a DNS name for. Basically, it's all going to work pretty much the same way. So you have a good understanding of how frequently it needs to replicate, how quickly, any stale replicas need to get invalidated. Not only can that all be tuned, but the values that make sense for that aren't going to change too much from one application to another. They tend to actually change more in terms of like human priorities. For example, if you allow a cheap shared web hosting company to manage your DNS, they are very likely going to try to set TTLs of a day or even a week on all your zones, which means that you go to make a change and it takes a day or possibly a week before anybody but you ever sees that change, because the TTL has been set so high. Now, did that happen because there was something unusual about your website? No, it happened because the hosting company wanted to cheap out and minimize bandwidth as much as humanly possible, and setting very long TTLs by default does exactly that. So they made a choice that made sense more for them and not so much for you. But again, this is why I say the only real changes on the DNS side are very human driven, and they tend to be kind of across the board for whatever that one set of humans that's managing that resource wants. If DNS had to handle as dramatically varied a workload as a regular database server, hell, even a key value store does, it would not be as functional distributed as it is right now, because there would be so much more complexity to deal with and so many more ways to get it wrong. And honestly, anybody who's ever actually tried to set up primary, secondary on bind, set up an actual cluster with automated replication, failover, and the whole nine, there are a lot of ways to screw that up too. Plenty.
But it actually reminds me that I think maybe one of the reasons that DNS works so well is they decided that we didn't need cache invalidation. It's basically, to your point, when you make a change, anybody could have cached this for up to 7 days or whatever, and it doesn't matter. Whereas we're not actually pushing out, hey, you need to delete all cache about jimswebsite.com. So by opting out of cache invalidation entirely, maybe that's what makes DNS actually work.
I think the final takeaway from all this is the one problem that you really can't solve, that people keep thinking has been solved, is you can't make a computer smarter than a person. And since you can't do that, that means there always has to be significant expert human involvement with any sufficiently complex computer system, and there's no way around it.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to 2.5admins.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy. Linux Matters for upbeat family-friendly adventures. Linux After Dark for silly challenges and philosophical debates. Linux Dev Time about developing with and for Linux. Hybrid Cloud Show for everything public and private cloud. And Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at 2.5admins.com/support. Why you can't trust AI to tune ZFS. This is an article on your website, Alan, that we'd normally just mention quickly, but I thought, why not discuss it properly for once?
Yeah. So based on a question that came up during one of our webinars, JT went and did a little research of what happens if you ask some of the most popular LLMs to tune ZFS for you, or how you should tune ZFS. How good or bad are the answers it gives you? Anybody have a prediction?
Terrible, and they should pay your company instead of asking AI.
Well, it's I would say actively harmful.
It's essentially like going onto a subreddit devoted to ZFS and asking the first random user to tune your system for you. You might get an expert who does a great job of it, or you might get an absolute mouth breather that's never had a good idea ever, and you don't know which one you're going to get ahead of time. And the reason for that is because guess what that model trained on when it came to figuring out ZFS stuff? A random grab bag of everything anybody ever asked or answered about ZFS, and all it can really produce is a sort of distillation of all of it without really any knowledge of its own about who said smart things and who said dumb things. It just knows what most people said with no real differentiators.
Yeah, it almost certainly read some of what you'd written, Jim. Surely.
Which is nice, but, as somebody who moderated RZFS for many years and, now moderates a private ZFS discussion forum, the quality of discussion varies greatly. I mean, honestly, the signal to noise is a lot higher at Practical ZFS than it was at RZFS, even when I was moderating it. But that's a little bit unfair, because the most involved, most interested users are the ones that followed me to Practical ZFS. And the punters that barely care are largely the ones that stayed in the subreddit. They do still have a couple of experts who check in pretty frequently in that subreddit. I look at it, although I almost never answer anything there, about once or twice a month. But the point is, while you can definitely find a lot of great information there, you have to be able to filter out the good stuff from the bad stuff. And as a normal human browsing a Reddit or a discussion forum, you can get a pretty good idea of who the trusted people are. You can check their citations. You can do a lot of careful things that an LLM isn't going to do and really kind of can't do because that's not how they work. A large language model really is pretty much just a jumped up word predictor, like the thing when you type on your mobile phone and it guesses what your next word is going to be. It just trains on a much larger data set and has a much larger set of compute resources allocated to it, but that's all it's really doing. It's guessing what the thing to say is based on what it's seen other people say.
Yeah, and crucially, that includes, as you said, experts, people who know a little bit, and people who know absolutely nothing.
Exactly.
It's worse here in that in some of the cases, I can clearly see where it extrapolated information from other things about ZFS and applied them to places they don't apply. For example, the very first one it looked at was the SPA slop shift. So this is the power of 2 that ZFS uses to decide how much space to reserve so that you don't run entirely out of space. So this is enough so that, when you're taking a snapshot or deleting a snapshot, there will be enough space that's not available to the user that the pool can still do copy on write and wait for the blocks that are no longer needed to become free to let no more writes continue. And it's specified as a shift. This is a programming concept where you take a bit and shift it number of columns over in binary. So a shift of 5 means 2 to the power of 5, which is 32. And so in a lot of cases, like the A shift that a lot of people in ZFS are familiar with, means an A shift of 5 would mean 32 bytes, which is less than a sector and wouldn't actually make sense here. And that's why an A shift of 9, which is 512, means the normal legacy sector size, and 12, 2 to the power of 12 being 4096, is the standard sector size now. Anyway, so the default value for SPA slop shift is 5. But it turns out it doesn't work the same way as A shift in this case. It is what percentage of the pool gets reserved. And so it's actually 1 over 2 to the power of the number. So 1 over 32, not 32 sectors, but in fact, it reserves 1/32 of the pool, which works out to about 3.2% of the pool, rather than 32 sectors, which would be a couple of kilobytes and 0.00001% of the pool. But the other thing it gets wrong is the fact that while that is the default and that's the value that's used, you don't need to tune this parameter anymore. Starting with ZFS 2.1 back in, was it 2021, I think? The SPA slop shift has an upper limit, no matter what the percent is. So it'll use 3.2% of the total size of your pool, but there's a hard cap of 128 gigabytes. so that, if you have a petabyte pool, it's not going to use tens of terabytes as slop anymore.
Now, the thing that I find interesting here is when we look at the mistakes that the large language model made with this particular query, it could have made the same mistake in at least two different ways. The way that it got the slop shift wrong, it could have on its own conflated the typical use of a shift in binary terms, as Alan explained it. It could have done that on its own and decided that, that meant that, this was how this worked. Or it could very well have simply been repeating errors that it saw people making in RZFS and other places, because that's also something that humans who talk about this parameter frequently get wrong, especially once you start getting into like the really esoteric stuff that like normal people aren't touching day to day all the time. When you see forum threads on it, there is so much confusion and misinformation. And if you're not capable of distinguishing the confused people whose ideas you should not be remembering for later use from the experts who answered all that stuff, you're going to have a problem.
Yeah. And then the fact that in this case, the answer to how to tune this value changed in 2021, and the AI doesn't seem to have caught on to that fact.
That's another issue. When the AI doesn't catch something like that, then you also have the thing of like, well, a conscientious human might very well have come across the older information, but would be like, well, let me double check that real quick with, current resources to make sure I still have this right. And that's a step considerably beyond the capabilities of a general purpose large language model. Some of them are starting to have, to some degree, they're able to look things up in real time, on the internet, not only rely on, what they've got vectorized from their training data set, but you're asking a lot there. To the best of my knowledge, even the LLMs that are capable of doing some limited web lookups in real time, they're not really bright enough to be able to say, well, I have the answer in my training data, but let me compare that answer that I think I have in my training data with current documentation and figure out what's correct, the current documentation or what I'm doing. They're basically just going to do one or the other. They're going to do a web search and tell you what the web search said, or they're going to tell you what they think they understand based on, what's vectorized out of the human language that they've ingested from their training data set. They're not going to do the one thing, compare it to the other, and then intelligently compare the potentially different two results to figure out which one is the one it ought to give you, which is exactly what a conscientious human expert would do. If somebody asked me a question about, slop shift, I would absolutely be looking up documentation first, because while I have the basics on board pretty well, I would know, I don't understand this well enough right off the top of my head to give people binding advice. I need to check it first. Maybe one day that sort of thing can be baked into a conversational model. It is not a feature in modern LLMs.
The next one is still the best. When asked about tuning the prefetch, it says the default is 10 milliseconds and there's no significant performance impact from increasing it. Actually, the default is 6,000 milliseconds or 6 seconds. And if you actually turned this down to 10, you would make the prefetch useless, because it would prefetch something, and if you didn't use it within 10 milliseconds, it would throw it away. And then when you actually needed it about 100 milliseconds later, then it wouldn't be there, and you'd end up doing all the work twice for no reason.
And so while this answer is a lot more shockingly and clearly wrong than the last one, we still have the interesting question. We really don't know whether it's because the model misunderstood what it read or because it read dumb shit and just accepted it as valid. Either way is a very possible way for getting these wrong ideas that it's confidently spitting out at you.
And so the conclusion to all this is don't rely on LLMs. Seek advice from an expert.
Not just for ZFS. Don't rely on LLMs for any kind of system administration, network administration, or architecture-related task. I think I've told this war story before, but one of my more recent contracts I wound up getting and replacing what at the time they had onboard salaried IT help. And the salaried guy on his last day where he was walking me around and showing me all the things proudly told me how he'd asked ChatGPT how to solve a Wi-Fi problem, and ChatGPT told him to replace a switch with a different brand of switch, and he did that. Now, why he proudly told me this when the actual problem had still not been resolved and the people who hired me had specifically mentioned this problem as something they were mad at this guy about and why they were replacing him, I don't know, but I'm just telling you, don't be that guy. ChatGPT is not going to make you a computer expert.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Richard writes, with things getting more and more grim in the USA, I want to set up a check-in service with a friend group that has some folks that could theoretically be in danger. My thinking is it needs to be low friction. I'd like clients to get a notification on their phones/computer at the end of each day. They can interact with the notification to say they're okay, and all clients would get a notification if anyone hasn't checked in within the past N days. At a high level, this would require some level of user management, phone notifications, and flags with timestamps. I'm wondering if a system monitoring solution like Nagios could be used in this way. I've been needing to set up such a thing for my home server anyway, although this check-in thing would be on a designated VPS probably, maybe even hosted in the EU. Anyway, that's to say, I haven't learned system health monitoring tools yet. I just know that Jim loves Nagios and would know about its viability for this, or other tools that might be simpler but still fit the requirements. I could create my own bespoke Python application on the back end, but I'm less familiar with phone app development. I'm not sure I want to trust myself with the security aspect of a fully self-developed solution. For that matter, I couldn't easily find an official Nagios phone client, but I know I've heard Jim talk about one before. Is it ANAG?
There are several Nagios clients for Android. ANAG is the one that I personally use, and I do recommend it. I'm not recommending any others, just ANAG is the one that I use, and I've been very happy with it, and I have turned a lot of folks onto it. Nobody's come back and said, why the hell do you use that? This one over here is much better, so I got to assume it's pretty good. On the iPhone side, there are clients available there as well. The last time I needed to look for one, I could not find a free one. I want to say whatever one I found cost like 10 or 15 bucks, and that iPhone user has been happy with it. In general, I haven't had that problem that much because my personal experience has been that typically iPhone users are not the users who want to be monitoring a health monitoring backend in the first place. But that's the situation there. Now, as far as whether Nagios would work for this, my first inclination was to say, yeah, Nagios would certainly work, but the big problem here is the way you want it to work on the front end. With wanting it to work with a notification getting automatically popped up on the user's phone on the front end, I don't think that you can really fit Nagios in there organically. I mean, you could certainly make that a part of your back end, but I think it would make things more complicated, not less. What would probably be the easiest thing for you to do, since you say you could create your own bespoke Python backend, let's just talk about maybe instead you just create your own website. And that way you don't really need to do phone app development. Your users are almost certainly going to be, or your friends, I should say, they're going to be using standard browsers, and all the standard mobile browsers, as far as I'm aware these days, they allow you that functionality where you can basically save a web page as an app of its own on the home screen of the phone. And so then if you tap it, it's open like an application and it can do things like it can push a notification to you. Probably with the skill set that you've hinted at that you already have, I think the easiest thing to do would just be to create a small private website. Depending on how paranoid you are, you might hide the entire web server behind a WireGuard instance and set up WireGuard on all your friends' phones. And if they're running your web page as like, a quote unquote application in the background on their phone, it can push a notification to them. They can interact with it. That can update a database, a simple database directly there on your little backend website. I think that's going to be easier than trying to build an app that somehow leaves a trace on the phone that Nagios can then call into and try to check the status. Like, I think that would be a lot more difficult.
Yeah, there's a couple of different ways I was thinking of this. The first one goes back to my very early setup of Nagios when phones didn't run apps yet. And I used the email to SMS gateway that my carrier provided to basically be able to send an email that would turn into an SMS and go to my phone. And you could do that with the URL to the today's check-in link or whatever to cause a notification. So rather than something that has to be running on their phone all the time, something running on the VPS, cron tab, or whatever is going to email everybody, maybe via SMS rather than email, that, here's your check-in link for today. And then they would click that and it would open in the browser and go to your Python web app or whatever. And then all you have to do is make something that if anybody hasn't checked in for X days, then send another alert to everybody saying, hey, somebody's missing, go to the web app. For privacy reasons, you might not want to say much more than that in the SMS and make them open the app and log in before they see who's missing or whatever. Or you might decide that maybe SMS isn't great, but maybe that's, hey, if the threshold is, if you haven't checked in 5 days, you're missing. At 3 days, we send you an SMS because maybe something broke with the app and you weren't getting the notification, as kind of a second step in the checking whether the person is just missing the notification or is missing.
I feel like the key part of this is you want to generate a notification on the user's phone for the whole seamless part. Another approach might be if all of your users either are already using Google Calendar or can be convinced to use a Google Calendar associated with, potentially a free Gmail account, if you get them to authorize a free Gmail account that, you use with your application, get them to authorize that account and say this account is allowed to set calendar notifications for me, then you could just set calendar notifications for all your friends each day. And when the right time comes up, their phone goes bingity, bingity, bing, and they get the link right there to tap to go to the web page and say, yes, I'm okay.
Yeah, that could be another easy way to do it that is more integrated with the phone that way, especially if they're all Android users.
The thing that I don't like about that one is that there's always a potential for friction when you start using a free service in an automated way, because the people who provide the free service usually aren't real interested in enabling your automation. What they really want is you, the human meat bag, to be interacting with it directly. You see that a lot with Google has made it very difficult to use Gmail accounts for things like, like to use them as SMTP gateways for copiers that scan to PDF. You see that in my industry, you see this all the time. The copier salespeople, they say, oh, we'll hook this up for you. They set it up to scan, using a free Gmail account as a gateway. It works for like 3 weeks and then Google does something and it breaks. And then you have to deal with that.
I was literally helping a school with that just the other day when Google switched to wanting OAuth 2 authentication for SMTP. Partly to prevent spam. It's like, our copier is never going to do OAuth 2.
Yeah. Now, with that said, if you could get your users to actually go through the one-time setup thing of making sure that whatever email account, your program is using is allowed to create calendar events for them, then everything should be pretty freaking smooth sailing from that point on. I like the fact that you don't have to install anything on anybody's phone for that. And that should work well for iPhone users as well. Even though the phone is not as directly expected to be integrated with the Google Calendar, you can absolutely subscribe to Google Calendars on the iOS Calendar app, and you will get notifications from those Google Calendars. So that strikes me as maybe the best way to go with it, honestly. There's not a whole lot of anything you need to do on the phone end. So that basically just leaves you creating a simple little back-end web page that allows your friends to say, yes, I'm okay. And again, if you want, you can hide that behind, the solidest thing if you're worried about security and privacy is don't make it publicly accessible at all. Require WireGuard to get into it. Now, at this point, now you also need your friends to install a WireGuard tunnel on their phones. And that may be moving you into more friction than you want, but it would get past any concerns that you might otherwise have about, well, what if the wrong person knows about my server? Like, how easy would it be for them to get in and check in for one of my friends or whatever you might be concerned about there?
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or your feedback. You can find me at joerest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.